Okay, welcome everybody to the second half of 4.3. Key concepts today are quadrant angles, reference angles, and periodicity. And really the big goal today is to be able to look at this problem, is to be able to, how do I say this? Quickly evaluate sine, cosine, and tangent of certain things. So being able to look at this and go, okay, I can do this without a calculator because there's certain things that I know. You don't know them yet, but for this particular example, this would be negative root 2 over 2. All right, now why? I don't know yet, or you don't know yet. All right, so we're going to get to this. This is kind of the big idea here, being able to do this really quickly in your head. Okay, so first we want to deal with the quadrant angles, the quadrantal angles. These are 0, 90, 180, and 270. And if you think about that on your circle, that's where all of the axes are. So 0 degrees, 90 degrees, 180 degrees, 270 degrees. Now, we can use your circle to help us figure this out. Since the sine is the y-coordinate, we could figure out that the sine of 0 is 0. Since the cosine on our unit circle is the y or the x-axis or the x-coordinate, we know that the cosine of 0 is 1, and then tangent is y over x, so it's 0 over 1, which is 0. Likewise, you continue using your circle. You need to become familiar with this, and there's lots of stuff that you'll memorize from this, which will be much better than just using the paper. All right, sine of 90, again, it's the y-coordinate on your circle, and therefore it's 1. Cosine of 90 is 0. And the tangent is y over x, so 1 over 0, which means it's undefined. And we continue this process. We start looking around the circle. We get sine, cosine, and tangent for 180 degrees, 0, negative 1, and 0. And then for 270, we get kind of the same idea here, negative 1, 0, and undefined. All right, so these are really, really, look at them. They're just so hard to memorize, right? Yeah, I didn't think so. All right, so the sine of 0 is 0, and that's something that becomes very important, especially when you start to graph. You might look at this and go, hey, these are kind of look like points on a graph. And they will be points on a graph. All right, next thing. This is the thing that we really want to focus on. This is going to be, how can I evaluate that sine of 315 that I had on the first page? These are called reference angles. So it's the angle formed by the terminal side of an angle and the x-axis. So we have angles. Kind of give myself an angle here. Actually, give myself some axes. And an angle in standard form looks like this. This is an angle in standard form, angle theta. Well, the reference angle is the angle formed by this terminal side and the x-axis. Well, in this case, it's this. This is, let's just call it alpha. This is the reference angle to theta. Now, the big idea is to be using our special angles, the 30, 45, 60s. And all of these are also in quadrants 2, 3, and 4. So what if I was to ask you for the angle 315? Hey, that's actually the number I was just using before, huh? All right, so if you looked at the angle 315, degrees, I want to know what's the angle created from the terminal side to the x-axis, which is right in here. Well, it's basically you think about, okay, how far left do I have to go to get to 360? Well, it's 45. And this whole circle has to equal 360 degrees, right? Okay, so the reference angle for 315 is 45 degrees. What about 4 pi thirds? 4 pi thirds. Here's where you have to start understanding how to count by fractions. Right here is 1 pi thirds, 2 pi thirds, 3 pi thirds, which is 180, and 4 pi thirds is right down here. I do not want you guys to continue putting these things in degree measure because I want you to be able to use radian measure fluently. Okay, so by putting it back into decimal or to degrees, you're not going to get a full understanding of the radians. So I want to think about 4 pi thirds. Well, I kind of gave you the answer as I was doing the counting, if you were paying attention. I had 1 pi third, 2 pi thirds, 3 pi thirds, which was on the axis, and I had to go 1 more pi thirds. So the reference angle here is pi thirds. Yes, it's a 60-degree angle, and yes, we could use things we know about 60 degrees for sine and cosine and tangent. All right, so reference angles aren't difficult, but they come in handy when we want to evaluate things. So here's how we're going to use them. I want to evaluate the sine, cosine, and tangent of 315 degrees. So we know that the reference angle for 315 is 45. And so what we can do is we can use what we know about 45 degrees. So I told myself to draw a picture, so let's see if I can draw myself a picture. All right, so 315 degrees is right in here. Now, some of you are just going to use your circle all the time, and I really hope it's not you. All right. The circle is handy to get the hang of things, but eventually we want to let go of that crutch. We want to be able to memorize. We want to be able to think through a problem. All right. So on the circle, I will use the circle as reference though. On the circle, you have a coordinate for this particular angle. And you could use this coordinate to help you out. But here's what I want us to figure out. I want us to think about the reference angle as being a special angle. All right? I know, or you should know, what the sine of 45 degrees is. Okay, so the sine of 45 degrees is root 2 over 2. Which means the sine of 315 is also going to be that number. You just have to figure out if it's positive or negative. And we'll get to the answer in just a second. The cosine of 45 degrees is also root 2 over 2. But again, since we're in quadrant 4, we need to determine if cosine of 315 is positive or negative, and likewise with tangent. All right, notice that I keep talking about the sine of 45 degrees, the cosine of 45 degrees, and the tangent of 45 degrees, because this is how the reference angles get used. Okay, so here's where I'm using the reference to the circle. Since the y-coordinate of a point on the terminal side of 315 is negative, so notice I'm saying the y-coordinate is negative. This tells us the sine and tangent are negative. You also know, I didn't put this in here, but the x-coordinate is positive. And remember, the sine is the y-coordinate, cosine's the x, and tangent is y over x. So it tells us sine and tangent are negative. So here's what I want to think about. Sine of 45 degrees is root 2 over 2. But because we're in quadrant 4 and the y coordinates are negative, sine is negative at 315. Likewise, for cosine of 45, cosine of 45 degrees is root 2 over 2, which means the cosine of 315 in quadrant 4, the x-coordinate is positive, and therefore cosine of 315 is positive. And lastly here, tangent of 45. Tangent is 1 at 45 degrees. And since the y-coordinate is negative and the x-coordinate is positive, that means tangent of 315 is negative 1. Now we could do this for anything in here. I'll bring up a blank page here in just a minute and we'll go over a couple more examples. Actually, I have examples here. I forgot I had this. All right, so evaluate a little faster now. I want to look at the sine, cosine, and tangent of 4 pi thirds. So the first thing you need to understand is what is the reference angle? Because the reference angle is a special angle that you should have memorized. Just do it. All right? Pi thirds. So this is a pi thirds reference angle in quadrant 3. So both x and y are negative in quadrant 3. So that helps us out. So that means sine and cosine are negative and tangent is positive. And I'd make sure you put this on your circle in each of the quadrants. Quadrant 1, sine, cosine, and tangent are all positive. Quadrant 2, cosine is negative, sine is positive, which makes tangent negative. Quadrant 3 is what we just said here. Sine and cosine are negative, tangent's positive. And then quadrant 4 is what we said on the last page, which is the sine is negative, cosine's positive, which means tangent's negative. So now, what do we know about sine, cosine, and tangent of pi thirds? For sine, cosine, and tangent, we get the numbers, let's see, sine of pi thirds is root 3, oops, then I wrote root 2. Root 3 over 2. Cosine of pi thirds is 1/2. And tangent of pi thirds is, what is this? Root 3 y over x. All right, so that means sine of 4 pi thirds is in quadrant 3, and therefore it's negative root 3 over 2. Cosine is negative 1/2. And tangent is positive root 3. All right, this takes some getting used to without just going straight to your calculator and without just going straight to your circle. Try these things without either of those pieces, okay? When it says evaluate without a calculator, that means you should be able to do it in your head. And you know me already, you know I like it when you guys do stuff in your head because I believe it makes you a better math student or somebody faster at math, okay? Which is a good thing. You don't always have to say, hey, mister, can I have another yellow sheet because I lost mine? All right, or can I have another circle because I lost mine? It's okay if you lose it because you should know a little bit about it before you lost it. All right, so we could do anything in here. If I said, hey, what's the sine of 150 degrees? Well, you think about it, 150 is right here, which means the reference angle over to 180 is 30. Well, I know the sine of 30 degrees is 1/2. And in quadrant 2, sine is positive, so it's 1/2. Notice how fast that was. And then you get to the point where you don't have to draw the picture anymore. Okay, I think I've said enough for this and how important it is that you just try these problems without the circle, without your calculator. All right, so the last little thing here is what we call periodicity. It's a very small portion. These 3 functions, actually all 6 of them, are what we call periodic functions. And they have one very special property. In our function f of x, there is some number that we could add to x that it just comes back to the same number. Meaning, this is kind of weird if you think about it. This is like a horizontal shift that comes back to the original function. Can you think of any function that would do that? Like, let's think about a quadratic. If I shifted it to the right 5 units, and it comes over here, is that the same exact function as before? Of course not. All right, what if, like a cubic, if I took a cubic and I shifted it right or left, it's not going to come back to the same function. Now, this is kind of weird because we've never dealt with a function like this before. But what this is basically thinking about the circle here. Thinking about the circle, this coordinate here on your circle is the coordinate 1, 0, which means the sine of 0 degrees is 0, cosine of 0 is 1. Well, I can go all the way around this circle, and now it's no longer 0 degrees, it's 360 degrees. Well, if I got to 360, sine of 360 is also 0. Cosine of 360 is also 1. Oh, but I actually didn't want 360. I wanted 720, which is just another rotation. And you notice we come back to the same coordinates every single time we add 360 degrees to the x value. Well, that right there is the period of sine and cosine. By adding 360 degrees, or 2 pi, we actually like the number 2 pi, it always comes back to the same point. And you can think about it as any point on this circle. If we were here, and this was 60 degrees, we could add 360, we could add 360, we could add 360, and we're always back to this same coordinate. Now, what I am going to tell you, for sine and cosine, the period is 2 pi. This is important to us, actually, when we get to section 4.4. And it's the same for cosecant and secant. But you notice I didn't say anything about sine or tangent or cotangent yet. Tangent and cotangent have a period of pi. And if you think about that, I just like to think about the 45-degree angle, where it's root 2 and root 2. Notice if I added 90, it goes there. But actually, if I want to add 180, this is negative root 2 and negative root 2, which tells me here tangent is positive and here tangent is positive. And notice it just comes out to the same thing. So we're adding 180 each time, or pi. All right, I hope this lesson was useful. You guys can work on this. We'll have a quiz the next day after this particular class day. So we're going to have a quiz on 4.1 through 4.3 on Friday, November 6th. I will see you guys in class.